Welcome everyone to this session. Good afternoon, and hope your Explore is going well so far. Today we'll be covering memory tiering, and I'll start with a question. Show of hands, how many of you here suffer from resource inefficiencies in your infrastructure? Oh, almost everyone. Things like CPU utilized, underutilized CPU resources, more memory consumed. There is, imbalance between CPU and memory. So we see this across the board with our customers. There is also this funny thing about software licenses. We talked to a few customers who spoke about software licenses being a challenge because it's nowadays almost all enterprise applications are per core licensed, CPU-based licensing. So for such a scenario, to get more effective utilization of all your investments, there is a need to get better in terms of usage of resources. So there is a need to get more efficient. So my name is Arvind Jagannath, and I'm a senior product manager at VMware for vSphere. And with me, I have actually a real customer, Brandon Frost, sitting here. He represents SS&C. He's a manager for the architecture at SS&C, and he will walk you through how he's managed to reduce the TCO in his environment with some real examples, how his infrastructure looks like before and after. So you will gain a lot of insights with a real customer study. So I'll start with the standard disclaimer. All right, so this is the problem statement, right? So the way we'll structure this presentation is, it's a set of simple slides. We'll start with the problem statement and potential solutions. So there are two solutions I'll present today. One that is actually available today, which is NVMe tiering. It actually featured in the keynote yesterday in the general session. So customers are able to use memory tiering today with 8.2U3. And then I'll also present an interesting project called Project Peaberry, which involves a CXL accelerator. And we'll cover both, and we'll also see some performance results, and we'll give you all a chance to ask questions too. So when we look at the problem statement, right, what we see across our customer base is memory, the way customers typically provision their or do their purchase cycles and provision their infrastructure is, they actually tend to right size their infrastructure. But what tends to happen is they right size it for the memory and make sure that all the memory is consumed for their VMs. Now they don't have any more memory remained to be used. But what we have also seen is there is a lot of spare CPU capacity, and it's very consistent. So this represents a wastage because, what if you could actually run more workloads, improve the density of your server infrastructure, right? So there is also the thing I mentioned with software licenses, right? We don't want to waste these software license resources. We want to make sure when customers actually deploy software licenses on a per host basis, on per core basis, it's fully utilized. So the problem is also compounded by newer CPUs because, as you all probably know, newer Xeons and newer AMD CPUs, they all come with more higher number of cores, and it's not going to stop. So both these vendors are going to increase their number of cores with each successive generation. So the first reaction we see is customers would like to add more DRAM, right? I mean, this is an easy way to solve the problem apparently, right? Just add more DRAM and see if you can increase the density. But unfortunately, it's not that simple because when customers actually, when IT admins provision their servers, they want to make sure that they can maximize their servers because they place their DIMMs in such a way it's populated, it uses all the DIMM channels, and thus they get really good bandwidth because it's spread out and they get good performance for their applications. Now, they can't really actually replace two because replacing will mean taking out a low density DIMM DRAM and replacing it with a high density DRAM. And the thing with DRAM, as you all probably already know, is higher density DRAMs cost exponentially a lot more, right? So it's far more expensive and it increases the TCO actually. So it's not as simple as take out your lower capacity DRAM and lower density DRAM and populate like a 128 gig DRAM, right? So it leads to a much bigger cost. Plus all this needs, extra power and cooling, etc. So now let's look at the next reaction, which is add more servers. Naturally, this is probably pretty obvious. Nobody wants to deploy more servers, especially when they see that their existing resources, their existing servers are not really being utilized fully. So it's kind of really a strange situation because now they have all these resources just sitting idle or not being used fully, and they are asked to actually deploy more so that they get more workloads capacity. They can increase their workloads. So, but the problem is again, it's undesirable because each new server means, you need to redeploy the software licenses. You need to allocate rack space, power and cooling, ports for HBAs, NICs. And then you also need, additional maintenance and OpEx. So it's not really simple as adding more DRAM, adding more servers, right? So VMware's unique approach is with page classification, right? So VMware has a lot of experience. I mean, I would say 2 decades worth of experience dealing with memory, right? I don't think there is any company which has researched memory at such levels. So starting from the days of, maybe 2 decades ago when we started working with vMotion, where we actually analyzed workloads, found patterns, and found ways to, reduce the performance impact on the workloads when vMotion is happening. So all this actually leads to, that expertise and that experience led us to work with Intel. So a lot of you here might have heard about Intel and Intel Optane and memory tiering with Intel Optane and how that potentially could have solved some of those issues, some of the same issues. We did work with Intel, but unfortunately Optane was end of life. But again, what happened was we started working on software tiering, and we did morph the project, and we actually then started looking at other alternatives like NVMe. And now we have the solution ready with NVMe tiering. And I'll show you some results with NVMe tiering too. So now when you look at our page classification, right? I mean, how we categorize pages and memory pages, right? So we can look at it as, categorizing it as unused pages or cold pages and warm pages or active pages. The other interesting thing is in terms of active pages too, right? When we look across the customer base, we don't see a whole lot of active memory usage, which means that at any point, how the workloads are really using the memory, right? So so what we have is memory tiering, which basically involves putting a cheaper memory tier and actually using intelligence. So all that classification and intelligence and being able to react really fast to any changes in the workload pattern. So basically we look very closely at the workload locality, how it's moving, how it changes, because performance is key for us. I mean, we want to ensure that performance is not impacted at all for the applications. So what ends up happening is, we get really efficient memory tiering, which actually can help move pages back and forth between the hot and cold tier. So the effect of this is we end up with a lot of host DRAM capacity. So remember at the beginning of this presentation, I said, a lot of customers have fully consumed memory. Now, this is what we are doing. We are actually making sure that there's enough memory capacity available on the DRAM itself. So now, if you think about it, more workloads can be fit into the same server without impacting the performance, right? So your existing workloads continue running, you can fit more workloads, and now your CPU is better utilized, and the imbalance between CPU and memory becomes lower now. So this is the first solution, and again, a lot of you might be familiar by now. This is NVMe-based memory tiering. We announced a tech preview of it with 80U3. This does allow you to take a release, 80U3 vSphere release, and actually try memory tiering in your environment. It's really simple to configure. Actually, it just involves checking a configuration option and also choosing a NVMe device, and that's it, and nothing else. And the interesting thing about memory tiering is your host memory shows up as a sum total of the host DRAM capacity plus whatever you allocate from the second tier. So in terms of affecting the workloads or making the workloads aware, customers don't have to do anything. I mean, it's automatically managed by ESX, the underlying hypervisor. So what are the attributes of NVMe-based tiering, right? Software-based. So it's completely built into our kernel subsystem. So it's part of our memory management. It has simple configuration. There are no add-on licenses, so it's available as part of VCF. Or vSphere, and any form factor NVMe device can be used, like an E3.S or PCI. So here are a few examples. So now let's move on to looking at some data. I'll present mainly on what we saw with respect to density, etc., and performance. So this is a login enterprise benchmark. Basically, this is standard benchmark, third-party company called Login Enterprise. So they allow us to test VDI instances on a server, right? So now when you look at the number of instances that can be supported, again, this is based on fully consuming the capacity of memory. On the left, you see 1 terabyte of DRAM only. And on the right, you see a 1:1 configuration. So what does 1:1 mean? It means one part of DRAM and one part of the second tier. So you get a total capacity of twice the amount, which is 2 terabytes. So when we allocate 2 terabytes, you get a linear increase, which is you get up to 256 instances now. And you get basically you get twice the density, right? Without compromising on any other aspect of your server. And it only gives a slightly smaller performance, only a 1% performance loss overall. Now let's look at a second result. So again, a lot of you may not be familiar with VMmark. VMmark is a standard benchmark from VMware. So it was built to simulate an average VMware customer. So it has, what we call tiles as a unit of measurement. So each tile represents a workload bundle. So basically, think about combining small and large VMs and then different types of workloads running within the VMs like databases, web services, Microsoft Outlook, etc., and combining them into a single bundle called a tile. So now when you look at these tiles and how they are scaling up with memory tiering, right? So the leftmost bar again shows, a DRAM only kind of a density. The middle one shows what is available today with 802.3. So you can scale up 33% by using a 4:1 ratio of DRAM to NVMe. So that basically means that, by just adding 20% more of capacity from NVMe, you can scale up to, 4 tiles. Which is, sort of represents a linear scale. And then in the future, we also already tested 5 tiles. So it means that when we use a 1:1 configuration, we can move up to, 5 tiles. And a lot of the NVMe devices do provide a lot of capacity. So you are able to do that. So basically, I want to end this section by saying that, if you, we have heard a lot of, we have heard customers a lot, and they are talking about costs, and with the new VCF, how their costs increased, etc. So this is a way to provide value back to you, right? Which is, we are looking at the fundamental infrastructure. We are trying to see where we can optimize as much as possible and provide value back to the customer. So try out NVMe tiering, and you will also hear from Brandon pretty soon. So let's move to the second solution, which we have been building for quite a while, and it's kind of revolutionary because this is one of a kind built in the industry. It's CXL-based accelerator called Project Peaberry as part of Project Peaberry. So CXL is Compute Express Link. It's a new protocol. It was developed about a few years ago. And what it provides is the ability for CPU to directly run its instructions on a PCI device. So they have enhanced the PCI spec and called it CXL. And the other ability is for the device to actually access host memory or track host memory in a cache coherent manner. So it offers all this, and it comes to us at a really good time because now as we are looking into memory tiering and other potential use cases, this allows us to use the good properties that CXL provides us as what we call a CXL type 2 property, and then use it for accelerating memory tiering even further. So the good thing about this is VMware is putting its IP in the device, and again there is no need to be scared because we have a really good team of architects who are designing this. We have really good partnerships too. And basically, we have a really good integrated design where the CXL device actually works very well with the host driver that we are developing too. So it's a good integrated solution. VMware is developing the IP inside the card. It's also developing the required support inside the ESX kernel, and it provides faster memory tiering capabilities. So one of the key things also with respect to the CXL accelerator is about jitter, right? So a lot of customers do not want to see latency causing a lot of performance ups and downs. On an average, it may look good, but we want to ensure that there is consistent performance overall. So the way we do it is we use CXL again, and CXL allows for reducing that amount of jitter or fluctuations. It's also capable of doing performance sensitive workloads, like take, for example, Redis or SQL, which I have some data about. it's auto-managed. So this is one of the key things I want to mention with the hardware solution. So we may have done other solutions in the past, but with this, we have put specific emphasis and attention to not actually add any more workflows or life cycle management or out-of-band management, nothing of that sort. So you take a card in and plug it into vSphere. vSphere will automatically recognize the card, download the required firmware and software components into the card, and it will work seamlessly without requiring any more changes. So that's key because, don't think that because it's a hardware solution, you will require many additional steps. That's definitely not the case. And again, no add-on license, and it provides up to 4 terabytes of total capacity. So the other interesting part about this is it represents an evolution because, now we are doing local memory tiering with CXL, with Project Peaberry. But soon we are also able to do remote memory tiering and memory pooling and vMotion improvements, which is VMware specific improvements, and also other use cases potentially. Because this is a custom hardware, we can do a lot more, right? So basically, the point of this is to show that once you deploy this solution, it's future-proofing your environment, because now customers 2 years down the lane, they can think about how do you consolidate memory across a cluster with multiple hosts. So these Samsung obviously Samsung is one of our partners, key partners working with us, and we have been collaborating for a while now, and we have other partners we are working with. And now let's look at VMARC results with Project Peaberry, right? So what we see, I already presented VMARC with the other solution, which is NVMe. Now this is VMARC with Project Peaberry, right? With the CXL accelerator. So on the left, you see again, you start with 3 tiles. And then when you move to 6 tiles, just with a 1:1.31, you can see 100% increase. I mean, if you recall, we saw a 33% and then a 66% increase. But now, you can directly get to 100% increase in the number of tiles or the workload density. This is again, another thing, important thing I want to share is we have been continuously working on benchmarking a variety of different workloads, and database is key for our customers. So a lot of, I think more than 90% customers use databases, right? So now on the leftmost, you see 100% DRAM only kind performance. Basically, it's to show that it's everything else is normalized to this performance. When you look at Redis, it's with a 3:1 DRAM to Peaberry ratio, you see up to 95% of the performance of DRAM. So you should recognize that it's not really about getting more performance. It's more about how close to DRAM you can get, right, at this point. So you're getting to up to 95% of DRAM performance with Redis. Now, the same thing with SQL. We also did a similar study for Oracle, and it shows a similar performance. With SQL, we can get 90%. The key thing, the difference here is observe the 1:1 ratio, right? So it shows that even with a 1:1, which means that 50% of your memory literally is coming from the device, you can see a performance as close to DRAM as possible, right? At almost 90%. So which means that both these workloads, and Redis is very active workload. It's a very active, very memory intensive workload, right? So for both these workloads, we can show really good performance, and really performance which is close to DRAM only. Okay, with that, I'll call upon Brandon Frost from SS&C. SS&C again is a financial services and healthcare systems software provider. And Brandon Frost has been gracious enough. He will walk you through what he's tried and what his experience has been. And we'll also leave some time for questions. Thank you, Brandon.
How about that, Morgan does? All right, cool. What's going on? My name's Brandon Frost. I manage the virtualization, architecture, and engineering team at SS&C. I've been there about 5 years now, traditionally also from finance. Our team does everything from capacity management to automation to ordering servers in some cases, deploying them, all of our design around the way we do clustering, vCenter deployment, all that stuff. So I have a great team. Some of them are here with me today, actually, which is great. SS&C is primarily a software company in the finance and healthcare space. So we do investment management software, asset management, healthcare stuff, and we also are kind of heavy on acquisitions as well. So we have a lot of interesting workloads, like basically every workload like you've probably ever heard of, every database, every type of operating system, everything, at least that you can run on VMware. We have all that stuff. So the way we wanted to kind of make that a little bit easier to consume is we have the what we call the SS&C cloud. It's a private cloud for our internal and our external clients where they can go and deploy workload from a web UI. They can pick how much memory and CPU they want. They get charged back. They can add volumes, do network security policy. We can even do automate SRM in the background for them through this web UI, which is pretty cool. So that's kind of how the platform gets consumed, which makes it kind of unique in the sense that, you know, I can't just go right size all of these workloads. Like these are customer workloads. People get charged back for these workloads. Like they need this, and it's not really in my domain to say, hey, you know, I'm just going to go beep, beep, resize it. They'll probably break something or a lot of things in this case. So on our right-hand side here, I talk a little bit about our growth. We grow about 3,400 VMs per quarter, about 23,000 vCPUs per quarter, about 90 terabytes of consumed memory per quarter, and about 75 kilowatts of consumed power. I like the power number just because it's interesting to me. What we need to look at too is the average VM size. So the average VM size really helps us figure out, okay, when I'm capacity planning and I look at historical trends for the past year, 2 years, you know, 3 months, 6 months, how do I forecast that out to say, okay, well, you know, customer demand, client demand, internal, external can be what it is. Like it ebbs and flows. We have some front-end capacity management where we get requests in advance, but overall, it's really a consumption-based model. So what we do is we use that average VM size, 4.8 vCPUs on average across the environment, 18.6 gigs of consumed RAM across the environment. And we take that number and we think, okay, well, if that's my average size, what size server should I buy? Let's assume, which your assumption would be correct, I'm trying to aim for about a 5-to-1 overcommit on the physical core. How much memory do I need now? So as we've kind of been growing this platform, data around that has been maturing. So let's go to kind of double clicking on that a little bit. So when we're looking, you know, at optimizing our performance or our purchases, our server shape, as I like to call it, with the memory and CPU, you know, core count that we want to use, we're thinking, okay, well, that's about right, but where is all that money going? Like, what are we spending all of the money on? And it turns out most of it is memory. It's all memory all the way down. And it made me think like, okay, well, man, that's a lot of memory. Like, that's a ton of memory, but what's it all doing? Is it doing anything? And it's not doing much. And that's kind of sad because it's very expensive. As you can see here, I took this stat a couple of weeks ago. It's 861 terabytes of consumed memory running in the cloud as of when I took the stat. Only 80 terabytes of that was active, hot memory actually being used. So I don't know, that's like what, 780 terabytes of just memory chilling, doing whatever it does. And that's great. So, and then you take that down a little bit deeper. So that means my VMs at 18.6 gigs of consumed memory, just under 2 of that is actually active on average. And then I look at servers too. Okay, so if I have a terabyte of memory consumed on a server, it's like 90 gigs of that is actually being used. So it's really, makes you wonder, okay, well, that's a lot of money being spent for that reason. And it gets worse actually, because I'm sure a lot of you, when you got DDR5, saw that the memory prices had increased quite a bit. And core counts are only getting denser, and you want to take advantage of that. Like for us, for example, last year I bought, a lot of servers. This year I bought 1/3 of the number of servers because we increased the density so much. But that means now I'm buying 256 gigabyte DIMMs. Those are very expensive, but it saves me a lot of power. I have a lot less servers to install. I have a lot more density there, and I don't have to plan my compute zones quite as large, scale out, rack space, port space, all that stuff. And I could just buy a server that's 4 times denser, but it's very expensive. So what I took here on the right-hand side for that little graph, I just assumed a server base cost of 27 grand roughly. And what you see on the right side is the cost of memory, list pricing. I just took that off a major OEM's website, but I thought it illustrated the point pretty good. So at the beginning, you're around 50% at 1 terabyte. That's like decent. You're getting up there 60, 67%. At the end, you're paying $166,000 in memory, list price, for 4 terabytes of memory in DDR5. So you times that by 100, 200, 400, 500. It's a lot of money that you're spending on memory. So looking at all that data, we decided maybe there's a better way. I started looking into Optane. Show of hands, how many of you guys use Optane? Okay, that's actually more than I thought. But, this is why the product is now dead, because I don't know what Intel was doing, marketing it really poorly, I guess. But I was a huge believer. So a couple years ago, I started buying lots of Optane. What I have there on that chart is the amount of Optane in servers I have today, almost a petabyte of Optane memory. And out of those servers that have Optane, there's 271 terabytes of actual DRAM. So what we did is we bought 512 gigs of DRAM per box, 2 terabytes of Optane. So just a quick note on that. You really need to look at your stats and say, okay, do I ever use 512 gigs active at one time on a server or not? Because that's going to help you figure out kind of what are you sizing for, and that also applies to NVMe tiering as well. This is why Arvin and I started talking, because after Intel announced that it was going down, I was like, okay, well, you got to help me out here, dude, because my boss is going to kill me, because we saved about 30% of our server cost just by going to Optane. And then you kind of take that number down even more, looking at the consumption side on the left there. What's really interesting, though, is 98.8% of the memory bandwidth being used on the host is from DRAM. That means basically all active memory is still in DRAM. Nobody even knew it was tiered. I never told anyone. I mean, now they know, so maybe they'll be like, I knew it was the memory. I doubt it. But and only 1.2% of that bandwidth on average was coming from persistent memory. So it was great. Everything was fantastic. It was all good. Unfortunately, Intel killed it, as I've mentioned. There's a few other things that didn't work with AMD, which, is kind of like the king in core count these days. Let's see what else. Yeah, occupies DIMM slots. So depending on the density you were going to go for, that didn't necessarily mean you were avoiding buying those denser DIMMs. It just meant you had to buy, roughly less of them. And then you got a slightly cheaper DIMM of PMEM. But it still is not cheaper than NVMe. NVMe is way cheaper than Optane was. And that's great, because really what we're looking at now is how can I save more money, especially now that I'm buying, 192 core boxes, 4 terabytes of memory like that. They're very expensive just to begin with. But I'm not, I know I'm not using all that memory. So what we want to look at now is NVMe tiering. I always was a big fan of NVMe. I think it's just getting faster, it's getting bigger, it's getting cheaper. Every server has front, NVMe configurations that you can buy. The drives are not that expensive. So I took that same chart from last time, and I did, like Arvin was saying, the 1-to-1 kind of ratio, which would work great for my use case, and kind of did the pricing there. Overall, it was roughly half the cost of DRAM, just across the board. And I never had to buy 256 gig DIMMs to get the 4 terabyte number. which is great. I mean, and that pricing there on the right-hand side, that actually includes the cost of the NVMe drive in the cost of memory. So way less, really looking forward to it. I'm thrilled that it hit tech preview. It's something that, I've been asking for a long time. And I think it is coming at the right time. So that's great. What other problems do we have, though, with memory? Like some of the other things that you'll notice, and I took this, this is an actual production cluster here. I just called it cluster A for y'all. But that is actually consumption. So I have a cluster. It has 63 nodes in it. It has 4,300 VMs, 126 terabytes of memory, and we're at a 5.5 to 1 overcommit on the cluster. Overall, that's about where I like things, especially in a general compute, generally like low octane type of environment. We see our resource usage there is about 64%. So that's consume memory. We do clusters across cabinets. So, there's a little overhead built in there in case we lose a cabinet. We can sustain that or leafs or, whatever. And about 3.5 terahertz of CPU usage. Now, I chose that number, or metric rather, just because truly we really measure CPU usage by ready and co-stop time, and we like to keep that on a low per core average. But I don't know, it's just easier to put like 3.5 terahertz. So what happens in the cluster though? Like it's a huge cluster. Overall, my resource usage is kind of like where I want it to be. I'm feeling pretty good about the consume memory, CPU's looking nice. I would consider this cluster about full, so I'm probably not going to be provisioning to this cluster anymore. But if you look a little deeper in there, even though we took all this work to do our average VM size and figure out, kind of how we consume the platform, one of the issues is obviously, as always, the snowflakes of the world come in and ruin your day, and that's what happened here. We have some old bare metal applications that we were virtualizing just because we weren't going to buy those bare metal servers anymore. And I mean, this can happen with a lot of other things. This could be you're consolidating from an older environment, maybe a specialized environment, maybe a client has a particular need and they have to deploy something wild, and that's what happened. So these servers, the hosts here, have 2 terabytes of memory. We had to deploy a few VMs. This was an in-memory database at 1.9 terabytes per VM. So it pretty much consumed all the host memory. And what we saw and what we see, and because I just pulled this like a week ago, is DRS is like, all right, cool, I'm going to put you over here. You're going to chill over there. And then all your other workload is going to get moved off because that host is out of memory. We're at 97% consumed on that host, but the CPU is at like 10%. It's like not being used. And then you look at the other hosts that don't have supermassive VMs on them. You see those are getting overcommitted quite heavily, 6.6 to 1, 8.2 to 1. I mean, but the memory usage is about average. So if I had more memory and it was cheaper, it didn't cost me 200 grand a server or whatever to add more memory, I could just do that. And then this would look a lot better. Maybe I would have more memory, but it's cheap, so I don't care. It's not like I'm spending tons of money on it. It's just there to have to make my CPU usage more effective. So actually what I did do this year is all the servers I bought this year, I did put an NVMe drive in them specifically to use with memory tiering. And I'm really looking forward to turning that on and some of these older clusters because I'm going to see issues like that go away. So with all that being said, I'm looking forward to it. Arvin's been great. We've been testing NVMe tiering. We've been moving some UAT workloads over onto it, just seeing how it reacts. And so far, I'm really pleased. I can't wait until it hits, GA and we can hit the button and turn it on, and that'll be great. But that's really it for me. So if you guys can go to the survey thing. Yeah, thanks guys.
Thanks, Brandon. It was excellent. So having a customer present his experience provides real testimony for you guys, for whoever wants to try it. So what we have with this scan code, the QR code, is for you an ability, an opportunity to provide your contacts so that if you are interested in doing a POC or a tech preview, you want to learn more, even schedule calls, Just scan this, provide your information so we can reach out. We can definitely work together on looking at your environment and see how we can help. And in the meantime, if you have any questions, I would also like to call upon Pratap, who's a fellow at VMware, and he's present today. So he can help answer technical questions, any deep questions, any questions at all you have. So we can certainly tackle those.
So I see the presentation. I say, wow, a new form of paging in ESX. You mentioned how it may or may not impact vMotion or other things. Are there going to be some services tuned to leverage it over real memory in the first place going forward?
So the question is whether vMotion is going to...
vMotion or other core services would favor going into the NVMe or the CXL memory versus going first into real memory and then paging out.
So vMotion is designed for a different use case, which is, when you have sort of a burden on the memory, and when you have, it doesn't really look into the CPU. Basically, when you have memory fully consumed, and vMotion looks at that, and it tries to move the entire VM. But this is a solution which is more finely granular than that. It will, vMotion is still present.
Yeah, I'm just going out when you vMotion or you evacuate a host, you have a mass amount of, especially if it's scheduled, you have a mass amount of memory copy, and running VMs have to go over, sync up, and you're going to start loading systems, and basically you're going to lose some amount of what was hot, what wasn't, until you reestablish what's hot. And
Okay.
Depending on the algorithms, if you go straight into DRAM, now you're pushing other stuff that you think is less busy out.
Right. Yeah, so Pratap, do you want to?
Just to be clear, nothing that you put today in favor of allocating pages on NVMe.
Yeah, and that's kind of what I was asking. Is there a future where it might? Because there are some things where you might, say it's critical, but it's not because we know it.
No, I think we would always favor DS.
Okay.
We will put NVMe only if we need to create space in the VM for runtime.
Okay. And the NVMe is still,
That's basically
like I said, I call it paging. Right, okay.
that's theory. It's not like we're going to favor this.
No, but there's some maintenance things you might say, I don't care if they're as fast as the world can ever spin. And some things that you just need to store, you're paging. So if you know you're going to do 1K of action, why hold the whole gig in memory to start?
Yeah.
It's okay.
There's lots of complications.
Yeah. By the way, we are actually making DRS and vMotion aware. We are adding more heuristics so that, it's not the same as moving a VM to a DRAM only host, right? So we have to take into account that there is a tiering involved now, and we need to be a little more careful about how we make these decisions. Go ahead.
Is there a way to scan the current environment to figure out which VMs have, cold memory, to figure out if it's actually worth it?
Yeah, good question. So I think we have monitoring capabilities where we can look into, the basic performance dashboards can give enough about CPU utilization and memory utilization on your system. We have performance charts that can show, how much is
VROPs can do it.
consumed. Yeah, VROPs can do it. You can also see active memory usage, right?
Mm-hmm.
So those things will give you an idea about whether you're ready for these types of solutions. So it's already there. Yeah, we have some of them.
So this is one bit of clarification. When Brandon's sort of presentation focused on using cost, the way to also think about this solution is that you have a certain number of cores in your computer. it's not usable because the critical resource is not. And you've filled up your critical resource. Now you can't use these cores because cores need memory to do something useful. You don't have memory. Right? If you clean up the memory and use push some of the useless stuff into NVMe drives or even the vBerry card, now these cores can actually do useful work because they have memory to play with. And the whole point of this journey is to make sure your computer is more balanced and that you get more for your investment. It is not to lower your investment, okay, which can happen if you want to, but it is if you're going to spend $100, you get your $100 worth from the infrastructure.
So, any more questions? I think we have a few more minutes. So please don't forget to take the survey, the VMworld survey, VMware Explore survey, if you get a chance. There is a different QR code for this. And thanks for attending. Thank you.
I know, I'm sorry.
Nice.